Alright, so here we have a 0.25 kilogram mass on a 1 meter rope is swung in a horizontal circle. The mass goes around the circle 5 times in 1 second. Find the tension in the rope. Okay, first of all, a horizontal circle. So that'd be like if you swung something over your head in a circle. The plane of the circle is parallel with the ground. Alright, as opposed to a vertical circle, which would be upright. Alright, but this is a horizontal circle, flat. And I don't know, looking at this problem, I see there's a mass moving in a circle. So feels like it's probably going to involve radial acceleration or centripetal acceleration, whichever you know, those things are equivalent. Alright, so I'm going to go with AC, because that's the one I learned, if it comes up. First thing we need is a picture. So if we looked at this from overhead, we would see the mass moving in a circle. Kind of. Alright, and there's my picture. Also, well, I need a free body diagram. Drew a picture, next step's the free body diagram. So I'll just draw it, at any point on the circle. I'll just use the point I picked. So here's where the circle was. There's a tension pulling it in right here, right? Now it has some velocity, which maybe I should note on my picture. Say it's spinning that way. It must have some velocity, but of course that's not a force, so it doesn't go in our free body diagram. What the free body diagram needs, though, is an axis. Now, the trick to problems with circular motion is to define your axis so one of them points toward the center of the circle. I'll call that the C direction for center, I don't know, or circle, whatever you like. And the other one, well, I'll just call it Y. I'm not too concerned. Oops. Okay, now of course you can name axes whatever you want. You could call this X or K, or it doesn't matter. I'm going to call it C because, well, I think it's the center of a circle, and that's probably going to be important. So there's my axis. Now that I've drawn a free body diagram with axes, the next step, without even thinking, is to write Newton's second law. Sum of the forces in the y direction equals mass times acceleration in the y direction. Sum of the forces in the c direction equals mass times acceleration in the c direction. Okay, so usually the next step is to ask ourselves, do any of the forces equal 0? Well, yeah, the y direction. But there aren't any forces in the y direction anyway, so that equation's rather boring. I don't think it'll help much. Over here I see that I have the sum of the forces in the c direction equals mass times acceleration in the c direction, AC. That is the acceleration toward the center of a circle. That is the centripetal acceleration, which is v squared over r, centripetal acceleration. I should define my r, right? There's v, there's r. So centripetal acceleration is always v squared over r. So that's why I like to name this the c direction if it points toward the center of the circle, because later AC pops in, and you know if you say AC to change it into v squared over r. Okay, continuing, that is a mathematical representation for MAC, but also it's literally the sum of the forces in the c direction. In this case, we just have positive T. Tension is pointing in the positive c direction, and that's the only one. So, from my equation here, I have mv squared over r equals T, the tension, and it looks like we may have it. I know r, don't I? Looking back here, r is going to be the 1 meter length of the rope. M, I know that's the mass of the block. But V, I wasn't exactly given V. If I can somehow figure it out, we'll have our answer. This is the tension. Let's see, can we figure out V? Well, looking back at the problem, as I often have to do multiple times in physics, We were told that the mass goes around the circle 5 times in 1 second. I feel like velocity is in there somewhere, that can tell us the velocity. Well, we know that velocity is equal to the change in distance over time. Okay, and so if I could just figure out the distance in 1 second, then I'll be good. And we can. If we go around the circle once, the distance is the circumference, 2 pi r. If we go around the circle 5 times, the distance is 5 circumferences, 5 times 2 pi r. So that's the total distance that it travels in 1 second. That's in meters, and that's in seconds. And so this calculation will give us our velocity. So we have our velocity, v equals 10 pi r in meters per second. You perform the calculation there. And so we can plug that in. So we get that t, so here's our other equation here. And for the answer, we get that t will equal to m, now it's v squared, so 100 pi squared r squared over r. And I see that I have r squared divided by r, so my final answer, I promise, will be t equals, shall we write, 100 pi squared m r. We know m, we know r. All right, so that was how to find the tension in this rope that's being spun in a horizontal circle. We mostly just used Newton's second law, free body diagram, the whole thing. The only special point was we needed to make sure one of our axes points toward the center of the circle, because that allows us to say that this acceleration in that direction is v squared over r. That was what ended up relating the velocity and the radius to the tension, allowing us to find the tension. So there we have it. All right, well, you can check out, if you like, another video on my YouTube channel or my website, physicscats.com, for another video similar to this one, but the circle is a vertical circle. Thanks.